Chapter 10, Section 9, Permutations and Combinations. In this unit, you will learn to find permutations and combinations. You have 3 vocabulary words, and as always, they can be found in the glossary in the back of your textbook. And let's get started. Our first word is the word factorial. Now, the factorial of a number is the product. Product means to multiply all of the whole numbers from the number down to 1. The factorial of 5 is 5 factorial. That's how you pronounce this. It's 5 times 4 times 3 times 2 times 1. And you read this 5 factorial. Now 0 factorial is a special case. That simply equals 1. So when you see 0 factorial, it means 1. Let's look at example 1 in your notebook. We are to evaluate 8 factorial. Well, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 factorial means 8 times all the whole numbers less than itself down to 1. And using a calculator, most calculators have a factorial button. I'll show you where that is on the school's calculators. If not, you just simply multiply it out. And 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 362,880. Now we can use factorials to multiply and divide just like we do other multiplication. For example, we have 8 factorial, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then in the denominator we have 6 factorial. That's 6 times 5 times 4 times 3 times 2 times 1. Now, looking at this, you know, as well as I do, that to reduce a fraction, and that's what this is right now, it's a fraction, you need to have the same number, same factor in the numerator and denominator. Well, if you look, we have that. We have a 2 on top and 2 on bottom. We have a 3 on top and 3 on bottom. We have a 4 on top, the numerator, and 4 on the bottom, the denominator. We have 5 in both the numerator and denominator, and we have a 6 in both the numerator and denominator. And we have a 1 down here in the numerator. Well, doing that, crossing all the common factors out, we simplify to 8 times 7, which is 56. And that's our solution. Let's try another one. Again, please pay close attention to this, even though it's not in your notebook. In this case, we have 10 factorial, and we're going to use our parentheses, so over 7 factorial. Well, 10 factorial divided by 7 factorial, we have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Let's do our canceling of common factors. 2's go away, 1's go away, 3's, 4 is the numerator and denominator, 5 is, 6 is, 7 is. So knowing that, we're left with 10 times 9 times 8, which is 720. And that's our solution. Now, a permutation is an arrangement of things in a certain order. For example, if no letter can be used more than once, there are 6 permutations of the first 3 letters of the alphabet. And I've listed them here. ABC, ACB, BAC, BCA, CAB, and CBA. 6 different ways we can write those 3 letters without repeating ourselves. Now, for the first letter, we had 3 choices. We had A, B, and C. We had 3 choices. For the second letter, we only had 2 choices because one of our letters were gone. So if we had pulled out the A for the first choice, the second letter would have to be B or C. So there's only 2 choices. Now if we pulled out A for the first letter and B for the second letter, third letter, there's only 1 choice. There's only 1 letter left, C. So the permutation of this can be written as a factorial. We had 3 choices, 2 choices, and 1 choice. 3 times 2 times 1 is 3 factorial, which also equals 6. So in total we had 6 choices in ways we could do this. Now, if no letter can be repeated more than once, there are 60 permutations of the first 5 letters of the alphabet, when taken 3 at a time. Okay, this is when this gets a bit confusing. But for the first letter, we could pick A, B, C, D, or E. We had 5 choices. For the second letter, let's assume A was picked, and our choices would be B, C, D, and E. We had 4 choices. And our third, we had assume B was chosen. So we have C, D, and E, 3 choices. Now we're going to stop there. We only want 3 letters. But we want to know how many combinations can there be. Well, it's 5 times 4 times 3, which is 60 permutations. Now this product can be written as a quotient of factorials. So 60 can be 5 times 4 times 3, as you've seen. Well, if I use 5 factorial, 5 times 4 times 3 times 2 times 1, I can cancel out 2 factorial to make it be that way. So if I want to write it as a quotient of factorials, this is how I can write it. The number of permutations of n things taken at r at a time is like this. Permutation of n things taken r at a time is n factorial over the difference of n and r's factorial. Kind of make sure you write this down in your notebook or someplace you keep it. This you will use throughout college. Let's apply it here. Jim has 6 books. To find the number of orders in which the 6 books can be arranged on a shelf. That's our goal, is to find the number of orders in which the 6 books can be arranged. So we have the number of books is 6. And the books are arranged 6 at a time. Okay, so we're going to have 6 factorial over 6 minus 0 factorial minus 6 factorial. So we have 6 factorial over 0 factorial. Now remember, 0 factorial is just 1. So we have 6 times 5 times 4 times 3 times 2 times 1 over 1. So that's going to be 720 over 1. So there's 720 permutations or different ways we can order these books. That means there are 720 different ways we can order the 6 books on the bookshelf. Let's try another problem. If the shelf has room for only 3 of the books, this is when permutations come in quite handy. Find the ways of 3 of the 6 books can be arranged. The number of books is 6. The books are arranged 3 at a time. So we're going to take 6 factorial, 6 minus 3 on the bottom. This is our n and our r. So we have 6 factorial over 3 factorial. 6 minus 3 is 3. So 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. 3 factorial, 6 factorial. We're going to do our canceling of common factors. So we have 6 times 5 times 4. 6 times 5 times 4 is 120. So there are 120 permutations. That means 3 of the 6 books can be arranged in 120 ways. Now I told you we were going to learn about permutations and combinations. What's a combination? It's a selection of things in any order. If no letter is used more than once, there's only one combination of the first 3 letters of the alphabet. ABC, ACB, BAC, BCA, CBA, and CBA are considered to be the same combination of A, B, and C because the order does not matter. Combinations, the order does not matter. If no letter is used more than once, there are 10 combinations of the first 5 letters of the alphabet, when taken 3 at a time. To see this, look at the list of permutations on the next slide. Looking at this, we have permutations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice that these in red are all the same combination because it's using the same 3 letters. And we're talking combination, so order doesn't matter. Likewise, these are all the same. These are all the same because order doesn't matter and they all use the same 3 letters. Likewise, these all use the same 3 letters. Order doesn't matter. So in the list of 60 permutations, each combination is repeated 6 times. The number of combinations is 6 divided by 6. 60 permutations, each combination is repeated 6 times. So there's an official definition and formula for this. The number of combinations n of things taken r at a time is c to the nr, which equals p to the nr over r factorial, which equals n factorial over r factorial times n minus r factorial. Let's try an example. Mary wants to join a book club that offers a choice of 10 new books each month. If Mary wants to buy 2 books, find the number of different pairs she can buy. Well, she wants 10 books, and she's choosing the books 2 at a time. So using our formula right here, using this formula, we're going to have 10 books and 2 factorial times 10 minus 2 factorial. So we're going to have 10 factorial over 2 factorial, 8 factorial. So when we write that out, we have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Here we have 2 times 1. That's 2 factorial. And then we have 8 factorial. So cancel the 1s, cancel the 2s, 3s, 4, 5, 6, 7s, and 8s. 2 goes into 2 1 time. 2 goes into 10 5 times. So what we have is 5 times 9. So there are 45 combinations. This means that Mary can buy 45 different pairs of books. Similar question, but part B. If Mary wants to buy 7 books, find the number of different sets of 7 books she can buy. Like I said, slightly different. 10 possible books, 7 books at a time. 10 factorial over 7 factorial times 10 minus 7 factorial. So that's 10 factorial over 7 factorial, 3 factorial. As you see, I've listed 10 factorial on top, 7 factorial and 3 factorial on bottom. We've canceled out common so far, but we can also cancel out this. 2 goes into 2 1 time, 2 goes into 8 4 times. 3 goes into 3 1 time, 3 goes into 9 3 times. So we really have 10 times 3 times 4, which is 120. So there are 120 combinations. That means that Mary can buy 120 different sets of books. We will talk about this more in class tomorrow, but we have one try this. Do your best on it, and I look forward to seeing you tomorrow.